There's a question physicists weren't supposed to ask. A question that was considered meaningless. Even nonsensical. What came before the Big Bang? For decades, the answer was simple. Nothing. Time itself began at the Big Bang. So asking what came before was like asking what's north of the North Pole. The question didn't make sense. But here's what they didn't tell you. That answer was never based on evidence. It was based on the limits of Einstein's equations. And now, the world's leading physicists are shattering that taboo. They're not just asking what came before, they're answering it. And what they've discovered will force us to rewrite the story of existence itself. The question that shouldn't exist. Let's start with why this question was forbidden in the first place. The Big Bang theory emerged from Einstein's general relativity equations in the 1920s. When mathematicians ran those equations backward in time, everything converged to a single point. A point of infinite density and infinite temperature. About 13.8 billion years ago. They called this point the singularity. And here's the problem. At the singularity, Einstein's equations break down completely. They give infinite answers. And in physics, that means they stop making sense. So physicists made a choice. They decided that time itself must begin at the singularity. Not that time existed before and we don't know about it, but that there literally was no before. The question what came before the Big Bang became a logical impossibility. Like dividing by zero. This worked fine for decades. Because we had no way to probe that moment anyway. But it always felt like a dodge. Like sweeping a difficult problem under the rug. By declaring the problem doesn't exist. And here's what most people don't realize. This idea that time begins at the Big Bang isn't a discovery. It's an assumption. We assumed it because our equations failed. Not because evidence proved it true. And in science, assumptions are dangerous. They feel like facts. Until someone comes along and proves them wrong. The Big Bang's fatal flaw. The traditional Big Bang theory has a problem most science documentaries don't talk about. It doesn't explain the bang. Think about that. The theory describes what happened after the initial expansion. How matter formed, how stars and galaxies evolved, but it says nothing about what caused that first expansion. Or where the energy came from. It's like a murder mystery that describes everything. Except the murder. This is called the initial conditions problem. The Big Bang requires the early universe to have incredibly specific properties. The right amount of energy. The right distribution of matter. The perfect expansion rate. If any of these were even slightly different, the universe would have collapsed back on itself. Or expanded so fast that matter could never clump together. The odds of getting all of this exactly right by random chance. Astronomically small. And then there's the horizon problem. The cosmic microwave background radiation. The afterglow of the Big Bang. Has almost exactly the same temperature in all directions. About 2.7 Kelvin. But according to standard theory, regions on opposite sides of the visible universe have never been in contact. They've never exchanged energy or information. So how did they end up at exactly the same temperature? It's like finding two people who've never met, speaking the same made-up language. In the 1980s, physicist Alan Guth proposed a solution. Cosmic inflation. A brief period right after the Big Bang, where space expanded faster than light, smoothing out all irregularities. But here's the twist, and this is where it gets fascinating. Inflation doesn't actually start at the Big Bang. It requires something to exist before. Cosmic inflation's secret origin. Here's what makes cosmic inflation so revolutionary and so controversial. Inflation solves the initial conditions problem beautifully. It explains why the universe has the properties it does. But there's a catch. For inflation to work, it needs a starting point. The inflationary field, the infl atom, couldn't have emerged from nothing. It had to exist in a quantum state before inflation began. In other words, inflation doesn't eliminate the before question. It pushes it back one step. Now we're asking what created the inflaton field? And the answer modern physics is converging on is remarkable. Eternal inflation. In this model, inflation never actually ends in most places. It only ends in rare pockets. Like ours. Our observable universe is just one bubble where inflation stopped. But the larger inflaton field? It's still out there. Still creating new bubble universes. Forever. This means our Big Bang wasn't the beginning of everything. It was a local event. Like water freezing into ice. The water existed before the ice. And if that's true, something existed before our universe. The only question is, what form it took? The bouncing universe. But what if inflation isn't the answer? What if something even more radical is happening? Enter the bouncing universe, also known as cyclic cosmology. In this model, the Big Bang wasn't a beginning. It was a bounce. The universe transitioned from contraction to expansion. Like a cosmic rubber ball. Bouncing forever. Each bounce is what we call a Big Bang. Not creation. Transformation. The universe never reaches infinite density. Quantum effects prevent total collapse. And force a rebound. In 2022, physicists developed models showing this could happen. Using physics we already know. Quantum mechanics and general relativity working together. And if this model is correct, time itself may be eternal. No beginning. No end. Just cycles. Each lasting hundreds of billions of years. Penrose's radical vision. Now we come to perhaps the most radical idea of all. Proposed by Sir Roger Penrose, Nobel Prize winner. His theory is called conformal cyclic cosmology. According to Penrose, our Big Bang was actually the end of a previous universe. A universe that expanded for trillions of years. Until it reached complete heat death. All black holes evaporated. All stars burned out. Only massless particles like photons remained. Drifting forever. In that state, time and scale lose meaning. Infinite space and infinitely small space become equivalent. So Penrose proposed a transformation. The end of that universe smoothly becomes the beginning of ours. Like flipping an hourglass. The end becomes the beginning. Penrose even claims there may be evidence. Patterns in the cosmic microwave background. Anomalous circles. Possibly left by black hole collisions from a previous eon. It's controversial. But if he's right, our universe had a predecessor. What this changes forever. So what does all of this mean? Whether it's eternal inflation, bouncing cosmology, or conformal cycles, one conclusion is unavoidable. Something existed before the Big Bang. Time may be eternal. Or emergent. Our universe may not be unique. We may be one chapter in an endless book. The Big Bang wasn't creation from nothing. It was transformation. And the fact that physicists are seriously exploring these ideas once considered forbidden, shows how far we've come. The universe is revealing its deepest secrets. And they are stranger, deeper, and more wonderful than we ever dared imagine. The answer isn't settled. But the fact that we're finally asking, testing, and gathering evidence, that alone is extraordinary. The universe is telling its story. And it's far more profound than we ever imagined.